Okay. So I'll wait for 2 minutes for everyone to join and then we'll start today's lab session. Okay, I suppose most of you have joined the lab, and so in today's lab, we'll be performing the implementation for our multi-layer perceptron that we had studied in our lecture. So, if you recall what we had studied in the case of artificial neural network, so in the case of feed-forward neural network, we had studied feed-forward neural network, which was multi-layer perceptron. A case of feed-forward neural network is multi-layer perceptron, in which we'll be having input layer, output layer, and a hidden layer, right? So in today's lab, we'll be performing the implementation of this multi-layer perceptron. Also, we can say that this is an artificial neural network. We'll be performing the implementation for artificial neural network. Wait a minute, let me share the screen so that I can inform you that what you are supposed to do. So I suppose everyone is aware about what was studied in the case of artificial neural network, which was, can anybody tell me? Anybody would wish to elaborate or share their views that what they recall regarding the same? Please unmute yourself and you can say all as well instead of writing in the chat section. Yes. Anyone? Okay. Should I randomly call any number and just ask, or anyways? Before that, just let us get through the brief of artificial neural network that we had studied, in which we had gone through. In which we had gone through that your network will have mainly consist of three layers, where you will be having input layer, hidden layer, and the output layer, right? And you know that why we will be implementing a hidden layer with the activation, non-linear activation function, along with why we are implementing using a non-linear activation function in order to allow some non-linearity, that is for allowing some high dimensional data. Whenever we want to perform classification on high dimensional data, it will be much better to go through with this, right? Okay, so in this case, we studied about two important parts of artificial neural network, that is forward propagation and backward propagation, right? In the case of forward propagation, what was happening was you will be passing your input data and passing through the hidden layers and to the output layers and generating the output. And in the backward propagation, you were calculating what is the error, and you were propagating the error backwards in order to update the weights associated with all the connection. And in this particular case, you will be having a fully connected network, that is all the nodes will be connected to each other. Okay, I suppose up to this everyone was clear. The basic idea is clear to everyone, right? Of this, yes. Okay, so now today we are going to perform the practical implementation of the same, where you will be utilizing PyTorch. So you have already performed an implementation using PyTorch in the case of linear regression, I guess, right? So you have performed the implementation, so you know some of the you are aware with some of the libraries and functions which are associated with PyTorch library. So now we'll be performing the implementation for MNIST dataset using the PyTorch library, and we'll be performing artificial neural network. We'll be creating a model, artificial neural network model, where we'll be passing the inputs. That is what we'll be doing. First, we have in the MNIST dataset, you just what I will suggest is you just go through what is the dataset, how the dataset looks like, and what are the dimensions of the dataset. So later on, what we'll be doing is we are creating, if you see, what we'll be doing is we'll be flattening the image to one dimensional vector. That is, we'll be creating 784 features. So in this case, your data set will be of 28 cross 28. It is consisting of images in the form of array. It is consisting of images of various digits. And here we'll be having in the output, you'll be having how many neurons? 10 neurons, because we are going to classify into 1 to 10 classes, whether the digit is in the class 1 or class 2 or class 3 and whatever other digits. That's why we'll be having 10 neurons in the output. And you can define as many neurons as you want in the hidden layers. And you can also add some of the layers in the hidden layers, right? So first we'll be flattening the images. This is all normalization part. In this part, you have to normalize the data set. And in the case of to implement using the PyTorch library, you have to convert them to tensor data set. Okay, tensor form of data set. So you have to convert your NumPy array to tensor form. And you have to also use data loader as well as tensor dataset and data loader to create a data loader form of data that you can load in the while iterating through the loop whenever you are performing the training. Later, you have to create an ANN model. So in the case of PyTorch library, you have a function called linear, which is used to create your sequential linear layers for the case of artificial neural network. And you can use activation function of your choice. Most of the practical implementation in activation function is done using ReLU activation function, but I would suggest that you perform experiments using different activation function as well, which is sigmoid, and you can use tanh activation function as well. Okay. So in this case, in the case of here you have to define your artificial neural network model. So first layer would be your input layer, and later on you can add as many hidden layers as you want. I would suggest try for 2-3 hidden layers and then create an output layer. Okay, so add activation function. So create an hidden layer, add an activation function, create an hidden layer, add an activation function, and so on up to output layer, right? So I would suggest add 3 hidden layers at this point of time. And in the forward, you have to call that particular layers for this particular data set. X is your data set. So your input data set that you have to call for it. But right now, this is a right now this is a brief diagram of how the code should go. You can use your own, you can perform your own implementation as well. You can define your own functions. And yes, there is a linear, nn.linear. I would write it in the chat box. So from linear is a function through which you can create the layers. Okay, just a minute. Okay, through which you can create the layers, and you are also supposed to add activation function. I would suggest that you go through PyTorch library documentation in order to understand that how you can create those layers and how you can pass your data set through the layers. Okay. So here I have already mentioned what is the input dimension, that is 784 neurons in the input dimension. I have also mentioned the hidden dimension, which is 150. You can add your own input dimension as well, maybe 200, or change the input dimension. And the output dimension is supposed to be 10 because we are going to classify the input data into 10 different classes. Since we are MNIST data set, the digit identification data set we have, right? So you can define your loss function. In this case, we'll be utilizing cross entropy loss binary that you recall. If you recall, in the case of logistic regression, we had discussed in the end about the cross entropy loss, right? Which is a generalized form of binary cross entropy, right? And so we have created, after creating, you define the loss, learning rate, and the optimizer, that is stochastic gradient descent optimizer, will be utilizing in order to perform the optimization process. And later on, you have to iterate the entire model. That is, first you will be clearing the gradients, you will be performing the forward propagation, that is, you will be creating the passing the inputs to the model and generating the output. You will be calculating the error, and later on calculating the gradients and update the parameter. Okay, the one we had done in the case of linear regression, same steps you have to do in the case of this also. So here the calculating gradients and updating the parameters, that is the backpropagation part in this case. Okay. Similarly, for the test data also, you have to create the output, compare it with the actual labels, and generate what is the accuracy of the model. And later on, you have to plot a visualization plot for both of these cases, that is iteration, number of iteration versus loss, and number of iteration versus accuracy. I suppose everyone is clear with what they have to do in today's lab? Yes or no? Okay. Now, after performing this, what first you have to create an ANN model. Later, since we have already got a brief introduction with the support vector machine, we have got a brief introduction. We know that what support vector machine is, main idea behind support vector machine. So I want you to also create an implementation for support vector machine with the same data set, that is MNIST data set. And I want you to compare what is the result that you are getting in the case of neural network by implementing the model using neural network and by using support vector machine. At this point of time, if you recall, in the previous lecture, I had discussed something called kernel function, which is to convert your data set into higher dimension so that it is much easier. For example, if your data is not linearly separable, then you cannot use a normal linear SVM to separate or to classify the data set. In that case, we'll be using certain kernel function to perform the implementation, right? But since we have studied only up to linear, so we'll be using linear kernel up to at this point of time and perform the classification on this particular data set. And I want you to generate what are the results in both the cases, in the case of ANN as well as in the case of support vector machine. So you have to perform the implementation of support vector machine using scikit-learn library, which you already are aware of, right? Scikit-learn library, I would suggest that you go through the implementation of it and create an implementation with support vector machine and this artificial neural network. And later on, we'll try to generate that what are the results that you are getting, and we'll also try to gain some insight in it. Okay, so I suppose everyone is clear now. Okay, fine. So I'm uploading this particular file in the classroom. Start your implementation. And if you face any difficulty, please let me know by unmuting yourself, and we'll try to solve this. And after 20 or 30 minutes, I'll ask for what is the update. Fine. So I have added the file in the classroom. Yes, I think Keval has a question. So there is a comment in the PDF to convert to float 32, and why do we need to convert to float 32? I think that is for the normalization purpose. We have to, if you see, after performing this particular part, you have to normalize it to 0 to 1. And you have to perform normalization. That is one of the ways in order to perform, in order to maintain your data, right? Achha, which value you need to convert? Yes, you need to convert the features. You need to convert the features to the float 32 format, and as well as the output, because I guess the both the value. Just a minute. Let me see. Where is this? Yes, yes. So you need to convert both of them to float 32 format and see what is the values that you are getting. And later on, you have to perform. You have to convert them to tensor format, right? Tensor data flow, right? You need to convert only the features, I guess, right? Not the target values. Yes. Yes, Priyank, multi-layer perceptron can be used for both classification and regression, but at this point of time, we'll be utilizing it for classification. Okay, I hope that is clear, right? Uh, okay, see, target values are those values which you are trying to classify the data into, right? So in this, the target values will be the classes for 10 digits, right? Yes, Priyank, I suppose the idea is clear that in the data set you will be having certain input data set as well as the target values. So in the case of classification algorithm, your target values will be the classes in which your data will be classified. So in this case, the class will be 1 to 10. That is the digits in which your data will be classified. That is, you are trying to classify your data set into 10 digits, right? So that's why that is what your target values will be. So in the case of multi-layer perceptron, whenever used as a classification algorithm, we'll be having an output. Right now, we'll be using a softmax in the output, a softmax activation function in the output, so as to state that you'll be having 10 different outputs in the output neuron, and each will be having their own probabilities, right? That is what we are using the target values for. And similarly, for the classification, for the regression purpose, your output will be in numerical form. So you may use a normal linear activation function in the output in order to get the output for the same. That is, so I guess your idea about the target function is clear at this point of time. Yes or no? Or still there is some doubt? Okay, I suppose the idea is clear now, right? If you still have any doubt, you may ask by unmuting yourself or in the chat box, right? Yes. So Prince, I guess. Yes, Prince. So that is a comment. We need to accumulate gradients. That is, it is trying to state that you have to convert them, the NumPy array format, into a TensorFlow format. In the tensor format. Since you are going with the PyTorch based implementation. So if you recall, in the case of PyTorch, in the linear regression also, we had defined that you need to calculate the gradients of all the variables that are present. So that's why you have to convert the NumPy into tensor format. That is main idea, and you have to define the learning rate. So I guess in the file itself, the learning rate has been defined somewhere. after a point of time there is a learning rate that is defined, that is 0.02, but you may define your own learning rate as well and try to perform the calculation, right? Are you getting the idea? Yes or no? Okay. Hello? Yes, Keval, you may present.
Hello, ma'am. Is screen visible? Hello.
Yes, the screen is visible.
Yes, ma'am. I am here visualizing one image, but how to ensure that this image is correct? That is my question.
Okay. Like in the case of testing, after testing the data, that is what you're
Yes,
asking?
here I am showing this data. Yes, after applying the converting into the tensor data set, here is the step. Like batch wise epochs, all I have done like converted into the test and data loader, and this is the step you have mentioned that visualize the images. So I'm visualizing image, but how to ensure that this is correct?
Means ensure that it is correct means if you are seeing an image of 2, is it showing the image of 2? That is what you are asking.
Yes, ma'am. Here I have passed that take a 5. If I take 10, then it will showing another features. Sorry, another
Okay.
image.
Yes, yes. Okay.
It will showing 3.
3 as an image, right?
Yes.
So I think so. Target train, feature train, and target is also showing the image 3 also, right? The title is actually showing the 3. You can see.
Yes, ma'am.
Yes or no?
Yes,
So
ma'am.
I think that is one way you can ensure that the image is you are getting is correct or not, right?
Yes,
Maybe.
ma'am. Yes.
Are you getting the point?
Yes, ma'am.
So the title is showing appropriate values. So
Yes.
maybe that is one way you can ensure. But after performing, so you have performed up to this. Now you have to go through the training process. I
Yes,
guess the
ma'am.
now, yeah.
Yes, ma'am. Now I have to create ANN model.
Yes, yes. So up to this, are you getting the idea? Now you are getting the
Yes, yes, ma'am.
correct. Yes. Are
Yes,
you
ma'am.
getting the idea? Yes or no?
Yes, ma'am. Yes.
Okay.
Okay. Thank
Okay.
you.
Okay. Yes. Yes, Keval. I suppose that is clear, right? NN dot linear is you may use NN dot linear for creating the fully connected layers, right? Okay. Anyone would like to share the screen and let me know where they have reached, or any doubts or anything that you want to discuss that you would like to discuss? Yes. Okay. Yes. Yes, Priyank. Okay. First, Priyank, you share the screen and then Janil.
Yes. Ma'am, is screen visible?
Yes, your screen is visible.
Ma'am, one doubt is there. This features value is between 0 to 255, right? In
Yes.
the MSI data set. But
Okay.
whenever I try to scaling between 0 and 1 by dividing 255, but it also
Yes.
shows that value 8 point something, and well, the not in between 0 and 1, but it also show getting more than 0 also, like here
Okay, you are
9,
getting.
8
Okay.
and something.
I see. Okay. Just a minute. So, did you feature strain 0? It is showing you values, but wait a minute. Just show me the output a little bit. 8 and all.
Yes,
Where
ma'am.
are the values? Okay. See. These are values are very small. There is e raised to minus 15 there. Are you know?
Okay.
Okay. So this.
Yes, ma'am.
Okay, so these values are actually, if you see, they are very small. They are actually in between 0 and 1 only. But since e raised to minus 15, what it will indicate? It will indicate the power to 10 raised to minus 15. So ultimately,
Yes,
these
ma'am.
values are small only. Okay.
Yeah,
So
yeah, yes, ma'am.
okay. So there is
Yes,
no
ma'am.
issue in this. Any other issue? So have you
No,
started with
ma'am.
the next part?
No, ma'am. I have done till this point.
Okay, fine. So now you have to convert them to tensor format. That is from NumPy to tensor, to in order
Yes,
to
ma'am.
deal with the tensor data set, right?
Yes,
Okay,
ma'am.
fine. Yes. Now, Janil.
Ma'am, am I audible?
Yes, you are audible.
Ma'am, let me check. Is my screen visible, ma'am?
Yes, yes, it is visible.
Okay. Ma'am, so here when I'm trying to pass this my model dot parameters in this optimizer, it is giving that it is an error that cannot
Empty
get.
parameter list.
Yes.
Okay, so show me from before. Okay.
Ma'am, I have created my model like this.
Okay.
That,
NN dot linear. Okay. And for hidden layers, you are mentioning how many hidden layers you are mentioning?
So ma'am, I'm doing from here.
All right, hidden features.
Yes.
Okay, input dimension is 28 cross 28, output
Yes.
dimension is 10, and hidden features, are you mentioning that? Okay, hidden features is?
So ma'am, it
Length.
would automatically map like add all the linear layers.
Okay, how many hidden length of, what is the length of hidden features?
1 second, ma'am. 2, ma'am.
Okay, 2
No,
is
sorry,
the length
3,
of hidden.
3, 3.
3 is,
Yes.
okay. All right, but, just a minute.
Okay, ma'am. Hidden features length. This one.
Yes, what is the
Okay,
length of
so
that hidden
For
features?
that, ma'am. This is the hidden features one. So
Yes, so the
One,
length of
two.
hidden features, so how many?
5.
3, 4, 5. So you are creating 4 hidden layers here, right? That is,
Yes, ma'am. So one
Okay.
second, ma'am. Let me do this like this.
okay. And in features is equal to hidden features J, where J is
J is 0 initially, and we keep increasing it.
Okay, you are from 28 cross 28, then 5 and 2, 256,
Yes, ma'am.
64, and 10. That is what you're doing.
Yes,
Okay,
ma'am.
I see. All right. Okay, go ahead. Then what you are doing?
So here, see, ma'am, I told you that list index out of range was coming, so I kept it -1 here.
Okay. Fine.
Now here-
See, just a minute. Go a little above where you have defined the forward function. So in the forward function, are you calling this function on your data? Self dot linears. Okay. Okay. Where is self dot linears? Okay. Okay. Feature from, you have converted them to features also.
Yes, ma'am. So initially I'm initializing out with X, and then in every linear layer I'm passing out. So
Okay.
it would get updated.
And then you are okay. Then you are returning out. Fine. Okay. Go a little down. Now. Okay. From here you are not getting any model parameters.
Yes, ma'am.
Okay. Did you just pass the model? Are you getting any value? Did you try the?
So here instead of parameters I should try model. That's what.
Okay. What is they asking? What are they asking in the optim.adam?
See, ma'am. I used it here in this.
Okay, you have LR. What is LR? Okay,
Linear
linear
regression.
regression you have used.
Yes, ma'am.
Okay. Mm-hmm.
So
Okay.
there it worked.
But here it is not working.
Yes, ma'am.
Okay.
But there I specified it like this. So is there some error in specifying it like this, or?
Are you getting any output? Just check that what is the after passing. Did you pass? You called the ANN, right? Where is this function that you are calling? ANN function that you are calling? Just show me that.
Yes.
ANN. Okay, here you are calling ANN. That is ultimately, just go a little up where you have defined ANN. Okay. There you have defined ANN function. Okay. I think, do you need to pass the data X from here? Is it?
No,
So-
ma'am. I will pass it from when I will call the forward method. There I will pass.
Forward
it.
method.
It is
Okay,
just,
have you called-
Yes, ma'am. Sorry.
ANN is actually defining your data set here.
Yes, ma'am. So
But,
initializing every linear hidden layers and everything.
Okay, maybe the definition problem may be there. I don't think so. It should be there actually. But try it once with that way and check whether you are getting in that way you are getting the output or not.
So, ma'am,
Just
if I'll take like this only. 1 second. From here only, let me take.
also, I would like to ask whether in ANN are you passing the input dimension on? Before
No.
that you had defined.
No, I don't need to pass because ma'am it is globally declared, so it would be accessible here.
Okay, wait a minute. Show me the function there. Okay, fine. All right.
So I'll take this.
Okay.
1 second. Yes, now it is working.
Okay, now it is working. So it was the problem with the definition, I guess.
Yes,
So maybe some problem is there in calling this linears.append because of maybe it is not working properly.
yes, ma'am.
Because maybe it is taking it as something else or output is not getting generated. Fine. So maybe the declaration problem is there. Fine. Still, if you face any difficulty, let me know. Fine.
Okay, ma'am. Okay. Thank you, ma'am.
Yes, Kevin.
Yes, ma'am. I have looked for the NN.linear definition. So in which it is asking for the in features and out features. But here we are passing in model like input dimension, hidden dimension, and output dimension. So what should I pass to that out features? Hidden dimension or output dimension?
Okay, in the first, see, in the first layer, you have to pass input and output dimension. So first layer will be containing what? Your input layer. And then
Yes,
hidden
ma'am.
dimension, in the function definition, you have defined in hidden dimension because in the succeeding layer that you will be creating, the input will be your hidden dimension. Yes or no? Are you
Yes,
getting
ma'am.
the
Yes.
point?
Yes,
Okay,
ma'am.
so ultimately, first in the first layer you will be creating with the input and output. Sorry, in the
Yes.
last you will be having output, but first would be input and hidden, and so on. Are you getting the point?
Yes, ma'am. But ma'am, how where to define these layers?
Okay,
That
in
I'm
the
not.
you have to define the layers in the this function that you are creating. So the init ann model class that you have created, in that you
Yes.
are defining a function init, right? There you have to
Yes, ma'am.
define the layers, and later in the forward function you call these layers, all the layers with the input x. Okay.
Okay, ma'am. That means I need to pass the that means layer dimension into function definition.
Yes. You have to. So in the whenever you call the model where you are calling it with the input, hidden, and output dimension, that means you are ultimately calling the function with all the dimension. But in the linear, you have to pass only two dimension, that is input and hidden, and
Hidden.
so on based
Yes.
on the layers. Okay,
Okay.
and final layer will be containing output dimension. Are you getting the point?
Okay, ma'am. Okay.
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 Okay. Fine. So Keval, I suppose you are clear, right? Because in first layer you will be passing with input and hidden. Your input will be input dimension and your output will be hidden dimension. In the second layer onwards, your input will be hidden and output will also be hidden, and so on. And in the last, it will be input will be hidden and output will be output dimension. Right? Right? Okay. Yes, you may use messy loss, but I would suggest, since we are going with softmax regression at this point of time, we'll be using cross entropy loss. Okay. Okay, anyone would like to share their screen? Should I randomly call numbers? Okay, okay, stop leaving the meeting. This is okay, 119. Okay, general, yes, general. Okay.
Is my screen visible?
Yes, your screen is visible.
So ma'am, I have done this from
Okay.
starting. I'm showing them. So these imports are there. Then I'm taking all the data, visualizing the data,
Okay.
and defining this hyperparameters
Mm.
and making this class
Okay.
model object is made. Then I'm converting to that torch tensor. Then
Yes.
I'm making a data loader, defining
Yes.
optimizer, defining the fit method.
Okay. Okay. Now you are calling the fit method. It is showing some error. That is
I don't know
dimension
why.
out of range.
In which one, ma'am? Initially I ran it. It was completely working fine
Okay.
because I
Just show
added
me.
that cross entropy loss and the.
Okay.
So ma'am, once again, let me make it MSC loss only.
Okay, it is working.
Yes,
But
ma'am.
okay, is it showing the epoch in error?
One second, ma'am. But there are too many samples, so it is taking so much time to.
Okay. Now it is showing some error.
See, ma'am, it is giving this warning also.
Okay, target size is different from input size. Torch size 10. Just show me where is the target size. Have you created a target size of 1? Output?
No, 10.
Okay, 10. Yeah, okay, fine. Okay, show me the fit function. Okay. Okay, did it show any how many error or epoch
Sorry, ma'am.
output? Epoch output has been generated or not?
No, because ma'am, I am printing after 5 epochs. So
Okay.
it is taking so much time to reach till 5 epochs. So what could I do is in this only I can print if possible.
Okay, that is one way you may try. Okay.
Because ma'am, I think it contains 60 to 70,000 images in one.
Yes.
That's
Yes,
why it is
right.
taking this much time. Also, ma'am, we have not reduced the dimension. This 28 plus 28.
Okay, you haven't reduced the dimension yet.
I mean,
Okay.
input dimensions are this much big now. So
Oh yes, right. Okay. Maybe just show me the function fit function just once.
yes.
Fit function. Yes. So you are evaluating for the testing data. Are you checking the prediction versus loss, batch losses? Right now you are going for
Yes,
only training data.
Yes, ma'am.
Only training loss you are checking.
Yes, ma'am.
Okay. Okay. Let me know if your epoch is generated or not. After
Yes,
a while, if it is generated, let's see what is the result. Fine.
Okay, ma'am.
Okay. Yes, anybody else would like to? Okay, 1110. 110 through. Through, are you there?